In this video we're going to look at hydraulic brake systems, both drum and disc. So when we're taking a look at a drum brake and its components and how a brake application is made and the transfer of heat through the shoes, the drum, and other components, and how each of these works. Now, when we're taking a look at air brake systems, hydraulic brake systems, most of the braking components are the same. There are some slight variations, but transfer heat through these is the same. Now, depending on what type of shoe we have, again, the weight of the vehicle will determine how big the shoe is. Again, we need that coefficient of friction to be able to stop that vehicle in a certain amount of time. So a very basic brake shoe. It has a single web on it. The lining can be either bonded or riveted. And there is usually 2 shoes per drum. Now, if we take a look at a very basic setup that we have for a hydraulic braking system. On this one here we have a single anchor point, and this is at the bottom. And at the top we have a double acting wheel cylinder. And on each side we have an adjuster, so as the shoes wear we can adjust this to bring the shoe close to the drum. Now on a brake application, in moving in the forward direction, the forward shoe because of the anchor point, the forward shoe, what it wants to do is, because it can't move off of this anchor point, it wants to get driven into the drum. And when it does that, it wants to create a high coefficient of friction. The rear shoe, on the other hand, because of the rotation of the drum, it wants to move it ahead and away from the drum. It wants to try and move it up. So the braking effort on this style, a non-servo, self-energizing because of the anchor point at the bottom, wants to move this shoe in, this one wants to move away. So most of the braking effort is by the forward shoe. When we're moving in the reverse direction, the opposite is true. The rear shoe is doing most of the braking effort, and the forward shoe is being forced away and up. When we have 2 leading shoes, so here again, what happens is we have an anchor point here and an anchor point down at the bottom. As we make a brake application, again, because of the anchor point, this shoe wants to drive in, and so does this shoe. So in this case here, both shoes are providing braking action. If we have double acting wheel cylinders, both shoes again are the same. And what happens here is, as this shoe, as we're moving in a forward direction, this one wants to push against this one. Now that's a non-servo type brake setup. Now when we get into a duo servo, so we'll see this on pickup trucks, trailers, electric brake trailers will do the same. So we have our primary shoe and our secondary shoe. So the primary shoe is on the front, secondary shoe is on the back. And one thing you'll notice is the secondary shoe has more surface area, more lining than the primary shoe. When you get them, they'll be marked primary and secondary, and I have seen them mixed up, where I've seen primary on the back and secondary on the front, where I've seen 2 primaries on one side and 2 secondaries on the other. So pay attention when you're installing these, and remember the shoe with the smallest amount of lining goes on the front, and there's a reason for that. So what happens in a case like this? We have our anchor point at the top, but down at the bottom we have our adjuster, which is not an anchor point. It just connects two shoes together, but it also has our adjuster for adjusting for wear. When I make a brake application, what happens? Well, the piston on the front comes out and touches against the drum. And what happens is it wants to try and rotate this shoe, and what it does is the primary shoe through the link is going to push the secondary shoe in. Now remember, we have an anchor point at the top, so the secondary shoe can't go anywhere once it hits that anchor point. So now the secondary shoe is doing the most braking, and that's why we have a bigger surface area for more coefficient of friction. We can we have a greater braking effort because of the size of the shoe. So when we take a look at our rear brake drum assembly, we're going to have our hub. Now we're going to talk more about inboard and outboard drums at a later date. But we also have our bearings and our seal. And again, all of these will help conduct the heat away from that drum through conduction. When we take a look at a simple rotor system, so again, rotors are better than drums for the simple fact that as they heat up, they want to expand. Well, they're going to expand into the shoe. Where a drum, when it heats up, wants to expand away from the shoe. So as that happens, we get less braking effort, we get what's called brake fade, and we can end up with a runaway. But on a rotor, when the rotor heats up and it expands, it goes up against the pads, and as long as we're applying a constant amount of brake pressure to that, the braking effort will increase. When we take a look at our pistons, how they're set up, and this is on a rotor type braking system, we can have a single piston, we can have a dual piston. The configuration depends on the manufacturer, how they're set up. So what we have is, again, our caliper. We have our pistons, which is number 5. We'll have a seal that prevents fluid from leaking out. We have a dust boot, and then we have a steel shield on the front. And then, of course, we have our bleed screw. So how, if we take a look at a drum brake, when we release the pedal, a spring will retract the brake shoe away from the drum. But what happens on a rotor style? Well, it's our seal that we have in the caliper. As we make a brake application, it deforms the seal. When we release the pedal, the brake fluid goes back to the master cylinder, and the seal itself pulls the piston back. And this is where, if we take a look at the heat shield, if it's distorted or if the boot's worn or falling apart, if we get dirt in here, the piston may come out, but it may stop. It may not allow it to go back in, and our brakes will drag. And every time we make a brake application, it's going to move out further and further. So it's something we should be taking a look at, whether or not our brake pads are wearing. So if we're doing a service, take a look, does the brake pads both, the pads both look like they're the same thickness? Are they even front and back? So we can tell if one of the pistons is starting to seize up, because the pad will be thick at one end and narrow at the other end. The other thing we want to take a look at is there's a thing called a floating caliper and a fixed caliper. So a floating caliper will only have 2 pistons. When we make a brake application, the caliper will be allowed to slide. When we have a fixed caliper design, we have 4 pistons, and we'll have a jumper line that feeds one side to the other side. Now, when I make a brake application, what's going to happen is the pistons won't move. Path of least resistance again. Once the pressure starts to build in the system, the piston with the least resistance is going to move out. But once it makes contact, pressure will build in the rest of the system, and the rest of the pistons will move again according to how much friction they have. This happens very quickly, and you wouldn't even notice the difference. Now, what happens as a rotor starts to wear? Now, as the rotor starts to wear and the pad starts to wear, Some of them will have what's called a squealer bar, and that's to let you know the lining's down to almost the limit and should be replaced so that we don't have steel on steel contact. When you get these pads in a kit, there may only be 2 pads with a squealer bar if all 4 pads are identical. Make sure you put them in the proper places. Now, what about the master cylinder? So our master cylinder has the mechanical link to our brake pedal. So when we make a brake application, the push rod is going to push onto the primary piston. And what happens then is we're going to take a look internally. So what do we have inside? So we have a compensating port. Now the compensating port compensates for wear. So as a rotor or a drum wear or a lining wears, the piston has to move out further, which means it's going to take more fluid. So the compensating port compensates for that and allows that fluid to enter the system to make up for the wear. Then we have an inlet port. Now an inlet port, what it does is as we're releasing the brakes, and we'll go into that a little bit later, we have our primary piston, which is a mechanical link to our brake pedal, and we have a secondary piston. We have our 2 brake reservoirs, and then we have a dust shield, which is a rubber shield that fits over top. Now what happens is as the brake fluid goes down, the seal moves down with the brake fluid, and this keeps the area between the bottom of the seal and the top of the fluid as small as possible to prevent a large amounts of moisture getting in and contaminating our brake fluid. We also have seals on our primary cup and our primary piston and our secondary piston. So the secondary piston cup prevents brake fluid from leaking into the cab. We have our primary cup seal that as we pass by the compensating port, it starts to build pressure. And then we have the same on our secondary piston. Now, depending on the type of master cylinder we have, the reservoir could be plastic, it could be part of the cast iron housing. The basic principle, whether it's like this or the one we just viewed, is the same. So if we take a look again, our push rod. Now let's just say that I'm changing this master cylinder. Something that we should be aware of is adjustment of the push rod to make sure that we do not close off our compensating port. Because if we close that compensating port off, if we adjust this as it pushes it in and closes this compensating port off, we can never compensate for wear. And you'll notice that as we make a brake application, the pedal gets further and further to the floor. So we got to pay attention to that when we're changing master cylinders. So in a release position, we have a spring here and a spring here that pushes our master piston and our secondary piston back out of the way, or sorry, primary piston. But what happens when we make a brake application? Well, as we start to push down on the pedal, what happens internally is the first thing that happens is the primary piston gets pushed ahead. It closes off the compensating port. What happens then is there's nowhere for that pressure to go once this is blocked off, so it has to go out the primary line. As the pressure builds, it then pushes the secondary piston to close off its compensating port, and once that's closed off, pressure can build in the secondary system and we can make a brake application on primary and secondary. Now, I talked about the inlet port. Why we have an inlet port? So in this area here, it's filled with brake fluid. Now when I release the brakes really quickly, what happens is the spring will push this piston back. We'll also have springs, let's say we have drum brakes. The springs will also help push it back. Now what will happen is it will create a negative pressure in the wheel cylinder. And when it does that, it could possibly draw air into the wheel cylinder. And again, as we know, air is compressible, and so we'd end up with a spongy brake. So to prevent that, we have our primary cup seal, which will fold forward. Now, if you take a look at primary piston, there's a bunch of holes drilled all the way around it. So as this primary piston comes back, secondary one does the same. Brake fluid is allowed to go through, force that cup forward, and allow fluid to go into this area here, which will prevent a negative pressure from happening, and it won't allow air to be drawn into the wheel cylinder. So once it gets back past a certain point and the pressure is equalized, the piston will come back far enough and the extra oil will come out the compensating port until we get a zero pressure inside here. What happens when we break a brake line? So a normal brake application, again, we have a mechanical link on our primary piston, but if our primary system is leaking, we can't build any pressure in here to start to push the secondary piston. So we have a mechanical link between the primary system and the secondary system. So instead of having pressure activate the secondary system, now we have a mechanical link. What would we notice? Well, we'd notice that the pedal would go down further. We're also going to get an alarm or a buzzer or a light inside the cab to tell us that we have a problem with our braking system. We'll go into that a little bit later. And then what happens is, now that we have a mechanical link, our secondary system will work. Our primary system won't. Now what happens if we have a secondary leak? Well, same thing as normal. We push on our primary system, we block off the compensating port, pressure builds in the primary system, and we make a normal brake application with our primary system. But our secondary system is now activated by a hydraulic pressure, and because we can't build any pressure in there, same thing is we'll get a light or a buzzer inside the cab to let us know that we have a brake warning, and our primary system is going to activate the brakes. If we take a look at, for instance, disc and drum brakes, so if we got discs on the front and drums on the back, the primary system will be the discs, secondary system will be the drums. Now why is one reservoir bigger than the other? Well, if you take a look at the size of a piston on the disc brakes, it has a larger surface area, which means it takes a larger volume of oil than the secondary system, the smaller wheel cylinders. Now, if we had disc brakes all the way around, both reservoirs theoretically should be the same size. Another thing that we have is a brake fluid level switch. And again, it all depends, not all of them have them. So as it starts to wear, or say we have some minor leaks and the level gets down to a certain point, this switch is going to trigger the light inside the cab to tell us that we have a brake problem. Also on the reservoirs, there should be a line that's full and low, and making sure it's filled up. Now, what about brake lines? Well, hydraulic brake lines are seamless tubing, and we use double flared ends on them, not a single flare. So how do we double flare? Well, there's a special tool. It's a flaring tool that comes with a double flare kit. So what we'll do is we'll cut the line off, we'll chamfer the edge, put it in the tool, put this one tool in, and it does this first crimp. Then we back it out, take this tool out, and run this in, and this will do the second crimp. Now there is an ISO flare tube, which is a little different, and there's a special tool for doing that. The other thing we might see, or we will see, on a rear differential and also on a steer axle is flexible rubber lines. And these are allowed to have allow the movement between the frame and the axle. And so as it goes up and down, it's not going to break a steel line. So we have flexible lines in there. One of the things to pay attention to when we're working on a steer axle is making sure that when we replace this front steel and rubber line, that we have them the same length as the ones we took off. We don't want it interfering and rubbing on the tire at all, so making sure that it's the right length. Now we've talked about brake shoes and how they work, but so now what we want to take a look at is a single piston wheel cylinder. So what we have is we have our cast cylinder, we have a boot, piston, and a seal. Pressure comes in the back, pushes up against this seal. This seal pushes up against this piston, and we have a rod that goes out to our brakes to make the application. When we have two piston wheel cylinder, now these can be the same size or different sizes. So we'll have a bleed screw, and again that's to get rid of any air that's in the system. And remember, a bleed screw always goes at the top, never at the bottom, because air rises in liquid and we want to bleed that air off. Pressure would come in. It will push on some of them. There's a steel cup in here. It will help force this seal out against the housing to make a proper seal, and then we have two pistons that go out, and of course we have a boot on each end, and that's to help prevent air from and dirt from getting in. Now one of the things that I used years ago is a thing called rubber grease. It's compatible with brake fluid, and you can put it inside these boots just a little bit to help prevent any rust. Again, remember there's moisture in this air, and if it gets in there it can rust this. Now what will happen then is that piston will come out and it won't go back in. So a little bit of rubber grease in there will help prevent that piston from seizing. And again, we could get a stepped bore piston, and again when we were taking a look, as we put pressure on a surface area, one piston here will generate more force. Other types that you're going to see will be adjusted wheel cylinders. So there's an adjustment ring on these ends to adjust for wear. When we take a look at a floating caliper, remember floating caliper and fixed caliper. A floating caliper, this is bolted to our spindle, and our floating caliper with a shoe or a pad on either side of the rotor and two pistons, and then we'll have this spring on the top, and all this does is help prevent vibration of the pads when we're not making a brake application. Now caliper assemblies, depending on the type of caliper you have, okay, so the most common thing is we're going to have a piston, we're going to have a boot, and we're going to have a seal. And remember, as we make a brake application, the seal flexes, and when we release the pressure off the back, it will pull that piston back into place, and that will pull the pad away from the rotor. Now, the other thing we have is we have these two pins, and this is on a floating caliper again, because what we want is, as we make a brake application, that piston has to pull both of those pads together on the rotor to make a proper application on each side. So that's what those pins are greased, and they slide, and allows this caliper to move back and forth so that we get even pressure on both pads. Now, what happens every time we make a brake application? What happens to the caliper? Well, it wants to pull ahead, and when we let it off, it goes back. We make another brake application, it pulls ahead. what happens is it wants to wear this piece out. So you'll notice if you ever take a caliper off, if it moves back and forth, you may have to install these stainless shims. They fit over top of here, so when we put everything together, it takes up for the wear. We don't want any back and forth movement in there. We want a little bit of clearance so that the caliper can slide, but we do not want them so loose that they can come out. The other thing we have is we have 3, 4, and 5, which is a spring, a key, and an Allen head bolt. And we don't want to forget to put these in, because this is what takes up the clearance once this is all together, to help prevent any vibration of the caliper inside our anchor bolt plate. So again, on a fixed caliper, because we have pistons on either side, pressure will be equal on both sides theoretically, and we'll get even braking on both sides. So there will be a jumper line that jumps from the one side to the other side, so we have a good brake application. So one of the other things that we see in a system is a residual check valve. So as it sounds, a residual check valve will maintain some pressure in the system. And again, we don't want air entering the system. So this will keep a small amount of pressure in the line itself. So as we're making a brake application, pressure can get through and push this off its seat, and pressure can go in. And what happens in the other way is it blocks it off. Expander cups, I said something about this a little bit earlier, is their little steel cup that fits over top of the spring, and when we make a brake application, it just helps the cup to seal properly. Brake failure warning devices. Again, if we have a failure in either the primary or the secondary system, we want to know about it. And again, one of the first indications would be that the pedal goes down further. So we want that warning to work. So how it's set up in the system is we have from our master cylinder, okay, it comes in. Now what happens if we take a look at on each side? Now this setup here, this goes to our rear wheels, and this here goes to our front wheels. Now we make a brake application, and theoretically pressure should equal on both sides and when we're making a brake application. Now if we break this line here, we cannot build any pressure here. Pressure in this side of the system is going to push this piston over. It's going to make contact with our switch and turn on light in the cab. Same thing as if we lose our front brakes, we can't build any pressure here. Pressure in our rear system is going to push over and is going to trigger this light. We also have what's called a metering valve. Now, a metering valve is in a combination valve, which we're going to talk about in a minute. So what the metering valve does is when I go to make a brake application, I want my rear shoes to apply first. Then I want my front shoes to apply, otherwise the vehicle could lose control. So what happens in the metering valve is as I start to build pressure in the rear shoes, even though pressure should be equal in both systems, this metering valve will not open and allow pressure to go out to my front brakes until I'm going to use 135 psi of pressure in my system. That will allow the rear brakes to apply first. Then I can make a brake application. Now in an emergency application, you're going to exceed 135 pounds instantly, and all 4 brakes will apply together. Now, one of the things when we're bleeding brakes is if we use a power bleeder, we may not be able to overcome the 135 psi, so we have to manually pull this out to allow the fluid to go out. If we're using a pedal and having someone step on the pedal to bleed the brakes, then we can exceed 135 psi and this valve will open. And where should we start when we bleed brakes? Always the furthest wheel cylinder away, and then work our way towards the front. This is what the metering valve looks like. So pressure comes in from our master cylinder, goes out to our left front and our right front, and this is the stem, and there's a special tool that you can use to put in there. Now in a combination valve there's three components to it. This is the second component. The first component was the warning device. The third component is what's called a proportioning valve. Now these can be automatic or they can be a manual one depending on the vehicle. So what happens is, if I have a vehicle that's got a heavy load on it or a vehicle that has a light load on it, I don't want to skid the tires. So what I'm going to do is the proportioning valve is going to look after that. And really, proportioning valve, what it does is gives, at a certain point, will give a proportion of brake application. So how does it work? Well, as I step on the pedal, brake fluid is going to come in here, and it's going to push again onto my rear brakes. Now, as it starts to build pressure, what's going to happen is pressure is going to work on this side of the piston, and it's going to push this piston back up against this seat and block off the flow here. Now that will prevent any more fluid from getting in, but it still will allow us to make a brake application. So how does that work? Well, pressure is still being built on this side, but now this small piston is going to push against this here. Now this is all filled with fluid, so what's going to happen then is, as this piston pushes here, it will generate a force or build a pressure internally. So if this surface area here is 1 square inch and 100 psi, we'll have a force of 100 pounds. Now we take that force of 100 pounds on 4 square inches and we have a force of 25 psi. So it's a quarter of the application force that's going to apply the rear brakes. And again, this is just to prevent wheel skidding. So again, once this is blocked off, pressure still builds in here, but it's going to work against this, and it's this piston here, as it's moving this way, is going to generate the pressure to apply the brakes. Now again, that happens to a certain point if we want to make an emergency application. Now, there is ones that are set up so that we can adjust them, and it will have a linkage, and it could be to the frame. And I had a customer come in one day and he says, yeah, I just can't really stop my vehicle. I don't know what's wrong with it. And what happened is the linkage had come undone. So as the weight gets pushed down on the frame, it changes how much this proportioning valve works. So when you got a full load on, the proportioning valve doesn't work at all. We get full brake application because we got the weight, we're not going to skid the tires. But what was happening with him is the linkage came off, so it never sensed the load, and he was having a hard time stopping. So once we figured that out, we just hooked the linkage back up, and he was fine. So what does a combination valve look like? Well, combination valve contains all three of these components we talked about. We got our metering valve, brake failure warning valve, and our proportioning valve. And they're usually just below the master cylinder. Understand what each one of these does. Again, what does the metering valve do? Well, it allows the rear brakes to apply before the front brakes. The brake failure warning valve lets us know if we have a failure in either the primary or the secondary system, and the proportioning valve will prevent wheel skid.